Okay. My name is Markus. This is Matthias, and this is Richard. And we all work for OMA International, which is Office for Media and Arts International. And we're going to show you the Nodekit. We're going to give you an introduction to the Nodekit today. And the Nodekit is an interactive toolkit for interactive graphics. It's a toolkit for interactive graphics. And how we arrived at the point to come up with a program like the Nodekit, I will explain now. The starting point of it all was the Tagtool. It was like 1.5 years ago or 2 years ago. We were working on a children's theater production. And the premise was we wanted to work with musicians and artists and actors on stage to tell a comic story for children. And the idea was that in the beginning of the play, we don't know how it's going to end exactly, or we don't know what way it's going to go to get to the end. So we needed something so we could tell a comic story kind of like in an improvisational kind of way. And we were looking around for different software that was available for drawing live. Nothing that was available on the market actually worked for us in a stage setting at that time. And we found a few options, but the thing was, nothing that was available on the market actually worked for us in a stage setting. Basically, you know, on a stage it's completely dark, so to work with a keyboard or a mouse, it's a no-go, or like distracts from the story that is happening. And if you are on a stage, you want to be kind of like showing something, you're a performer, you know. So basically, after a little while of research, we realized that we had to come up with a solution of our own to realize this story. So back then, we started the Tactile to be on the stage as a presence with a monitor stuck in front of your face. It's also not a good idea because it's kind of project. We basically made a drawing software that is made with a tactile controller. So you draw basically using a Wacom tablet. And the key thing is that there's no menus or parameters that you change unless you actually use tactile controllers. So if you want to change the color, for example, doesn't work? No. Why not?
Because of the latest version and the keyboard.
Oh, then just...
You need a keyboard to get out of the...
Okay, so hang on a second. Nimm mal dein Keyboard kurz. Ah, okay. Yeah, we were just putting the latest version of the Nodekit on this Tagtool, and apparently it doesn't work in this setting, so we just have to revert to the old version. Na, es muss neu starten, die alte Version. That's it. Okay. So we'll give you a glimpse of how the Tactile concept works. You have 6 faders on this machine, which basically controls the different aspects of the brush while you draw. Like the first one is the hue of the color. Like when he draws and I move the slider, I can kind of like slide through the whole rainbow to get pretty much any color I want. The next fader controls the saturation, which means kind of like how strong the color comes through. So when he continues drawing now and I move the saturation fader down, it slowly moves towards white. And if you have it kind of in the middle, then you have sort of pastel colors like this. The next fader controls the brightness. So with that one, you can go from completely visible to black. And you can also draw over the other strokes, of course. And the next one is a transparency. So when you draw with this one over other lines, you'll see that they'll come through transparent. This one is kind of useful to kind of layer up colors a little bit like you would do with paint. And then the last fader basically controls how fast a finished drawing will fade out over time. Because when you finish a drawing, like this, you press the red button, which releases it. And because I had the fade slider all the way up now, it started fading out. And if I keep the fade slider down, and we have drawings, then even though he has released them already, they stay on the screen. Now you have a couple of released drawings on the screen, and that's where the gamepad comes into play. With the gamepad, you can cycle through the different drawings and select each one, and then you can move it. You can kind of move it around, or you can scale it. You can rotate it as well. And then if you like a movement that you did, like say we want this one to rotate, there's a possibility to make the movement stick, and then move on to another drawing and put a different movement on this one. And if you want to have more dramatic changes, there's also a way of moving all drawings at the same time. So you can kind of get very visual effects like tunnel movements or something like this. This is great for clubs like fast drum and bass or whatever, you know. So that's basically the concept of the Tactile. It's as simple as that. And we try to keep it more or less that simple because we want it are incredible at what they do, but they don't have the first clue about computers. And we don't want to exclude them from using the Tactile. So to work with kids and with people that don't have a computing background, because it's amazing how many artists are out there that, like in our experience, it works great. People can, like even old people, we've worked with like a 70-year-old artist, and even he, within like 5 or 10 minutes, could understand the concept, and he did amazing animations. And he was completely blown away that he, as a 70-year-old man, could fabricate real-time animations. So basically this is the Tactile. It came out of an idea that was born out of the children's theater. And shortly after that, we kind of like got in touch with some people out of the street art scene. And that's where the name Tactile comes from, because it was just great fun to hang out with like graffiti writers and have them practice their tags and do like projections on buildings and play with the shapes of the buildings. So it's not the same as graffiti, but it has a lot of connection points with graffiti. So the whole street art graffiti side of it became like a very constant part in the development of this instrument. And just to mention it, like from children's theater over graffiti, we also got in contact with architects or people that wanted to use this in presentations as a sort of whiteboard, or even for animation, like people from other scenes to present them what our idea and what you can do with it. like people that produce music videos and they want to draw over the videos or something like that. So like for post-production stuff, and even with social workers, like there's one here actually. Now, we had great experiences with getting together a bunch of kids and having them communicate over the wall, you know, drawing over the wall, and it's an activity that was kind of very satisfying for them, and I think it works great in a social work context as well. And so on. It just proved to be a concept that fits into very many scenes, and that's one of the reasons why we're very glad to be here today, because it's another scene that I think has a lot of connection points with the Tactile, because it's based on software to a certain degree. And this is where I want to make my bridge to the Nodekit. Because while my friend Matthias is drawing here, all the time the Nodekit is running in the background. Basically, everything you see and the whole controls and everything is represented by nodes that run in this editor. And if you look around, the Tactile program is actually quite a large network of nodes. So project, we were constantly changing to different environments. And for example, we would be at a VJ gig where we wanted to jam with VJ, and we wanted to be able to exchange data over MIDI and OSC. So we modified the program to have MIDI and OSC capabilities. Then we went to a multimedia theater where we wanted to interact with the technology they had there. So we wrote, for example, some code that could interact with the motion detection equipment that they had there. And in the end, it was the best way for us to have the whole program composed out of building blocks. So when we move to a new environment, we just fabricate the building block, and then we can decide to drag it in and connect it to the program and use it, or just leave it out. So basically there's like a core Tactile program and introduction to the Nodekit. And if you have any questions now, you can already ask, because I think it's best to have this like more like a kind of open talk, so where you can interrupt if you don't understand something like that. But do you have any questions? Because then I would hand you over to my colleague Richard, the guy who programmed pretty much all of the Nodekit. And he will talk you through some of the basics of the programming of the Nodekit. And he will show you how to create your own node. If you have an idea of something that would work in this context, you can just create your own node and integrate it into the whole thing. We can extend it with whatever module we want to work in pretty much any environment we want to. Well, I guess that's the so.
Ja, oder nicht. Some problems appeared. Okay. Okay, my task here is to introduce you in the programming of the Tactile, of the Nodekit, the software is called. And as Markus explained before, we have a lot of nodes here. They are in groups, ordered devices, graphics, mischannelers, and method. Here we are. Okay. I have here a little document which introduces in the it's quite simple UML diagram which shows what's the main parts of the architecture. This is the base node. All nodes which are defined here are derived from this base node. You can see metrics. And I will now explain how you can program your own node, a custom node, and to plug it into the Nodekit. There are output slots and input slots for each node. Each node can have an arbitrary number of slots, outputs and inputs. The basic idea is to connect output slots to input slots, and even if output slot changes its value, all connected input slots will recognize this event. And the node then, owning the input slot, then is updated and the outputs are then changed again. I will show you this in a little example. Maybe I take an addition node and some other. I can drag the connection here. We can click on this connection or delete it or so on. And if I enter now any value here, then the result is transmitted over the wire here, and here comes out the tenant. If I add 3, 13 is the result going here. And so I can add my values. And for the more, probably we want to do graphics. We have a screen node, which opens here a display window, and the display have some inputs for the graphics. For example, I put in a star, or it's more a triangle, now it's a star. Good. Now I think we can step over to programming. The main thing of the base node is that it has an update method in which all work is done when any input changes. In our example, we will program a node which is calculating the modulus, the remainder of a division or a fraction. Main thing is to import. I must say before, all is written in with a .NET framework in C#. Graphics uses throughout OpenGL, and so we are capable to do 3D graphics or 2D too. Now for our modular node, we derive from base node, declare our input slots, mainly our number we want to divide and the modulus, and an output slot for the result. Now I must explain, the Tactile is programmed so that the UI traverses these classes per reflection, and on each slot it met during the traversal, it generates the corresponding GUI element representing that slot. And so they are marked here with an attribute, and these attributes are searched by the GUI and creates then for each slot such a panel. So in our constructor, I named this my class because it's arbitrary how the class is named. In the information attribute, I can put my name, which is shown here in the GUI. In the constructor, I create first a string designating the name of the slot. For example, by addition, we have here the A. We have another statement. We can set the slot active or inactive, which means an active slot generates an update of the owning nodes, and a not active slot is so-called passive and do not update the owning node. Then we can set the pass callback function used to enable this editing field that converts that string standing here to the data type the slot accepts. In our case, the data type is given by this number, a double, and which is the allowed argument for that slot. In the case of an output slot, we put only the data type the output slot produces and set an initial value. Now, even on each change of this value property, the output slot generates an event which informs all connected input slots about this change. Now, the main method and only the important method is the update method. In our case, we want to calculate the modulo. Slots, I will explain only for the number argument. Input slot, each slot, as you can see, has an owner. This is in this case this. I do here with doubles because the most numbers in the Nodekit are doubles, and so there are no problems with compatibility with other nodes. As you can see, I calculate simple the modulo of the number value and the modulus value and put this to the result. This assignment operation here generates the event of the update of the connected slots. So you have nothing more to do. And if I will open now my environment here, and I have here this example to compile. I will not show how I write it. We compile it simply, copy the resulting DLL file to our Nodekit installation. It's a debug build. Another thing is to say the spelling naming convention is to put the second part of the file name is used as the group name in the Nodekit, then here for MISC, MAT, and so on. This is maybe a little faulty or not so good, but currently it is so. So I have here my Nodekit installation, and in the plugins folder I put it simply in there. Tell the thing it should load it. Now I got my new nodes. I have another node programmed, for example, that we show next. As you see, I have my modulo, for example. 10 divided by 3 must get 1 rest. So this is a very simple example, and you see it works immediately. You have not too much to write. The main thing is to write the update method. Here you can decide the sender. Here is the input slot which generated the event. There you can decide what you do in your node. And there exists another initialize method which is less important, but important when loading or saving a network. This initialize method should initialize the node after loading the patch. A patch is, we call the network a patch. Okay, now we'll introduce how can we make a node which produces graphics. This is the more interesting part. In the Nodekit we have a namespace called Tactile graphics, which implements the main graphical classes. They're quite simple. You can create a so-called direct shape where you can call GL vertex or GL color and so on, which is called immediately on each frame. You have the possibility to create display lists or vertex buffer objects. In our example, we will simply draw the OpenGL teapot by calling the glut function. For this purpose, we must derive from our direct shape class. This is an abstract class containing a render method. In this render method, I draw the object. We have one parameter, the scale for the size of the teapot. Node, the node which represents that teapot in the editor. We have our size as input slot and a shape as output slot. As you can see, the value of the size. Now, even on each change of the size, we simply create a new teapot. You see the shape's value is a new teapot, which is defined before. Again, we set up a parse function for converting with this size and put in a transformation of all 0. The result of the teapot is this node. I drag it in. If I connect this, I have my teapot transforming. I do this again. For that we use a transformation. As you can see, and what do I wish? I want to move the teapot with the mouse. Then I draw in the mouse node. You can see when I move the mouse, the location gets out to here. Now I want to transform my teapot, drag it here. But this is not simply all. We want to see it moving, and if I attach now, for example, the translation, the values are a little bit too big. We scale the values. Turn it in the right direction, and you can see the mouse now moves the teapot. and it's quite simple. Are there any questions? It is not so far. We are not even begin with it, but there are the most. Not really. We are working on it to get it running on mono, but problems are in the devices. There is much work to do, and we are thinking about this.
Sorry, yeah. So, do the nodes that you already have support any video streaming or loading or anything like that?
No, we thought about it and we are working on it, but just it's not released. And currently we are able to record drawings or anything, and we are able to play back these drawings and render it out as single frames.
Okay. The other thing I want to ask you is a bit about motivation, about making this, because I don't know if you know, but there is something called pure data, which follows a very similar principle of, with what you're doing. Sorry? Yeah. So
I will give over.
Yeah, maybe that's time for me to take over, and that was exactly the kind of questions I was going to address now. So.
Not easy.
Okay, so I'm going to start addressing the question about other platforms that are based on a similar principle. When we were in the situation that we were looking for the right technology to realize our idea of a live drawing program, an animation program for stage, we were checking out a couple of different environments, like Isadora by Mark Cornelio from Troikatronics, Quartz Composer on Macintosh, Chitta, which is like an extension of Max MSB, Pure Data, V4, and similar environments. And each one of them has their reason to exist, but we couldn't find exactly what we're looking for. The first problem was that most of them are not open. Like for Quartz Composer, for example, it is possible to write your own nodes, but it's a hack. It's not officially supported by Apple. It's like you have to look on obscure forums, and it might work, but when they upgrade it to the next version, it might not work anymore and stuff like that. So we don't want to develop software for our company and for our projects that is controlled by other people that might have different plans for it. Pure Data, yes, it was the one that came closest, but it's made for audio, first of all. And to get it to the stage, to do what we can do with the Tactile, it would have been as much work as writing it again. So in the end, we kind of like decided to we saw that there was a lack of completely open source software. This is an important aspect of the Nodekit that I forgot to mention so far, that it's open source. It's licensed under the GNU GPL .2. And yeah, we didn't find any software that was completely open source, that was node-based, that could fulfill our requirements. And that was the motivation to actually start this project. As you can see now, I mean, the principle is there, it is functional, and as you can see with the Tactile, you can do very complex things and do them in a production environment and do like large-scale projects with them. Obviously, the Nodekit itself was developed by us for us, especially in the beginning. And so there's a lot of things right now that are not really so intuitive because we understand them, but there's not enough documentation to tell people how it works and to make the learning curve easier into it. So our big priority for the next few months, or maybe even years, is to take the principle that we have here and make it available for a larger audience and to make the learning curve easier, to improve the GUI and to work on some architectural concepts of it to make it even more consistent. So it's an even better base for large-scale projects. And that's kind of like the question of what is the future of the Nodekit project and the Tactile project, because they are very tied actually. Well, I mean, the Tactile project has been really interesting for us so far, and it has taken us pretty much around the world. We've been in a lot of countries in Europe with it, and we've been in South America as well, Argentina and Brazil. And there's a community of people spread mainly around Europe that have built their own tag tools and that use the software for their own purposes. And it's a great thing to see this grow, and we want to continue to support that. And the other thing is, like, our personal plans for the Nodekit is, now that we concentrated on getting the tag tool to work in the state that it is now, we want to shift the focus to work on the Nodekit as a platform and realize other projects apart from the tag tool with it. And the thing that is on the horizon right now is like an as yet unannounced project, which we are working on together with a group of Argentinian artists, which is an interactive game that is played in the street with participation of passers-by and the audience. And our platform of choice for this is, of course, the Nodekit. And while we continue to develop this, we want to improve and polish up this platform. Do you have any questions?
What kind of inputs do you plan? I think like videos, camera, or something else, music. Is it possible?
Yeah, it's definitely possible. Right now, it's not possible yet to use. We have no video node yet, but using the same principle that you just saw, it's possible to construct a video node, and it'll be. It is on our roadmap, but we can't give you any definite time when we will do it.
Okay.
Maybe somebody else will do it before us. You know. It's open. It's open for people to grab it and change this to whatever they need it. You know.
It's not a question. Do you have some demo to show us both of your instruments working together?
You mean
the software and the tablet?
Okay, the demo is here. If you could switch the video stream again. Yeah, I mean, this is basically the second prototype of the tag tool, and it shows the working together of the Nodekit with the hardware. Basically, there's a PC in there running Windows. There is an Arduino in there as well, which is a microcontroller that translates the signal from the faders. Oh yeah, he has an even better one. Yeah, you see here, this is the Arduino board, which is also an open source project. The signals from the faders is taken into the Arduino and converted inside and put into the computer over USB. I can give you that to have a look if you want.
Is there an equivalent graphical interface to get practice? For training without constructing it?
Yeah, that's a good question actually, because a lot of people would like to try the Tactile, but they don't want to build a Tactile first before playing around with it. So the answer is, if you have a graphics tablet, you can try it as well. But what you need as well is a MIDI controller or something like this, because we have MIDI capability in the Nodekit, so you can replace the Arduino node with a MIDI node and connect up the connections the same way, and then you can change the color and everything with the faders of a MIDI controller. And obviously, like, this question has been on our minds because that's one of the feedbacks we got, that people wanted to be able to try it out quicker. So in the next version we're going to release, we are also going to have a version of the Tactile patch that works just with mouse and keyboard, which obviously is not as intuitive and you can't have pressure and anything, but it demonstrates the concept.
Just a very simple question, but is there any plan for audio?
There is. Actually, I mean, right now we only have plans for a very simple audio node that plays back waves. And this is for that game I was talking about. But as you saw, it's fairly easy to construct your own node, so you just have to figure out how to play a wave file and put it into the node, and then you have an audio node. But it's kind of funny because most of the other node-based editors out there started as audio projects, and with this one it's the other way around. Like, we wanted to draw first and build everything around it, and now we're kind of like reverse engineering the editor for it. It's just the way it happened. Maybe one thing that could be interesting is the immediate plans, because we are just shortly before releasing a new version of the Nodekit, which has one big new feature, which is the recording feature that Richard mentioned before. It basically means that when people have drawing sessions out in the street or wherever, with a Tactile, when you press a certain combination on the gamepad, the screen flashes red and everything will be recorded. So yeah, well, yeah, we tried to put the latest Nodekit version on the Tactile now, but it didn't work straight away. So we'll not demonstrate it now, but it'll be out in maybe 1 or 2 weeks, something like that. And it's, yeah, first of all, you can record drawing sessions, and secondly, you can after that play them back at speeds up to 15 times. And you can render them out in an arbitrary resolution as well, so it's possible to create HD videos of drawing sessions that you had. And after that, the release after that will be one that will be focus especially on the Nodekit and getting the UI a little bit more intuitive, writing up tutorials, and just reviewing the whole experience of using the Nodekit for the average user that hasn't used anything like that before. Okay, I think that's it for now. If you want, you're free to come up here and just have a play with the Tactile. And yeah, enjoy. Oh yeah. That's one thing I forgot to mention actually. Our main source of information about like the artistic project we do with the Tactile is we put everything on our blog tagtool.org. For people that are interested in the development of the Tactile and the Nodekit, there's the Tactile developer zone, which is tagtool.org/developer, which is one part of the website that we want to boost in the future and make a kind of like community around it. And yeah, that's the best sources for Tactile information right now. There's also a Flickr pool with images, and we put videos on Dailymotion and Vimeo and stuff like that. You will find them if you look for them.